All right, thank you everyone for joining. If you are seeing this, it means you are watching the live stream. So please ask any questions that you have as I go through our topic for today. I'm going to walk through some quick slides and then show you all a demo where we're going to do some file integrity verification with hashes. At the end of the demo, I'm going to go back and circle to all the questions that you all asked and hopefully make you all experts in today's topic. I'm so excited to have you all here. Please let me know where you're coming from in the chat, and let's just jump straight into it. All right, so I'm Franz Pear with Skyline, and today we're going to be verifying file integrity with hashes. I'm going to show you how you can generate hashes from files and then compare them to see if a file has been tampered with. So let's just go and jump straight into it. When it comes to file hashes, you've probably heard of the term hashing used in many different other contexts. So let's just explain what it is for a second. Hashing is a method that lets you take an arbitrary amount of data and compute a fixed length output, which should, and the should here is very important, be unique. And the output that you obtain from running the data through the hashing function is called the hash. So you've probably heard of a lot of different hashes. I mentioned file hashes. There are also password hashes. Hashing is used in a lot of different situations. Now, in any case, when there is a change made to the input data, no matter how small it is in the input data, it should produce a hash that is different. And so this is where it comes very handy when it comes to something like storing passwords, for example. So if you have a database and you have user information, you might want to store passwords so those people can log in, but you probably don't want to be storing it in plain text, because if someone breaks into your database and steals all those passwords, well, now all of your users' passwords are out into the world. So that's very bad security. What you might do is run their passwords through a hashing function so that if your database does get compromised, it's not the passwords that are out there in the world, it's the password hashes. And the hashes are a little bit more secure because when people are going to log into the website, they're going to have to type in the password, and then it goes through the hashing function. And it should be very easy to get the input and generate the hash, but it should be very difficult to go the other way around. It should be difficult to take the hash and figure out what was the input that generated that hash. So that's why hashing is very popular for being used in securing people's passwords in databases. It's also used for our topic for today to identify and prevent file tampering. So you can actually hash a file and get a fixed string of characters that will represent that file. And so if any small change is made to that file, you should get a very different hash. So just like with the passwords, instead of just having a single password going through the hashing function and generating a hash, and then you compare the hashes, you put the file through the hashing function, and then you're going to compare the file that you currently have and the hash that it generates with whatever hash you might have on record. So to actually prevent the file tampering, you have to generate a hash of the original file. Some time passes, and you run the hashing function again, and you just verify this is the same file or is it not the same file. And this is used very commonly when you are looking at maybe downloading a file off the internet. When you download that file, maybe something happens in transit, maybe something gets messed up, maybe there's an adversary that is giving you the incorrect file rather than the one that you mean to download, and you can verify the hash of the file that you downloaded with the hash that was listed from your source and see if they're different. And if they're different, it's a clear indication that something went wrong in between. Maybe it's just a benign thing, maybe it's a solar flare, maybe it's actually the case of an attacker coming in and manipulating your file transfer. And another common use for hashing is to perform efficient data lookups. So this is used a lot in computer science for saving data and looking it up by a key rather than by an index. And hashing is a very efficient way to go and do that. Now, I mentioned that it is very important that you have a hashing function which should be producing unique hash values. Once in a while, because there is an arbitrary amount of input data, an infinite amount of input data, and there's a fixed length of the output, it will happen at some point. You'll get what is called a hash collision, where two completely different inputs produce the same hash. And that's just to do with the key space. If you have a finite number of possible outcomes, number of possible outputs, and an infinite number of possible inputs, there are going to be some inputs that map to the same output. This is called a hash collision. And you want a secure hashing function, which means that it is not possible to force a hash collision. So let's take an example of why this could be a problem. Say you have a popular repository that a lot of different devices are using to connect to for updates. And the maintainers of these repositories will often list the files, the update files, with their hashes. So if someone attempts to run an update, what their computer will do is it will pull the download from the server, and it will look at the file hash that is listed on the server, and it'll compare and it'll see, do I actually have the correct file that matches the file hash on the server? Now, if an attacker is somehow able to break the hashing function and they can create their own file, which is a virus, and then maybe they add some sort of padding just so the virus matches the exact same file hash as the original file, they could then do something nefarious where they trick the computer into installing the virus, thinking that it is actually a legitimate update because it matches the file hash of the file from the update server. And there's a lot of different ways this could happen. It could be a situation of a man-in-the-middle attack, or it could be maybe the attacker has the ability to upload files, but the ability to update the file hashes is a separate set of security credentials. And this is why having a secure hashing function is very important. All right, so let's just go over how hashing works kind of visually, so this is a little bit easier to understand. On the left here, we've got our data. The data can be anything. Like I said, arbitrary length of data. So we have, in this case, let's just say it is an image. You can see here the ASCII representation of this data shows PNG. Those are the magic bytes for the PNG image file. And that's going to go through your hashing function, and then you're going to get your hashed data that is going to be a fixed length of characters for your input there. And there are a lot of different common hash functions that can be used. There's MD5. It's extremely common, unfortunately, because MD5 is not considered a secure hashing function. There have been some research that has shown that it's actually possible to force a collision with MD5, although it's not particularly trivial, but it is possible. And then you've got some more secure functions like SHA-1, SHA-256. There's a lot more different SHA iterations out there. There's a ton of different hashing functions. You can definitely go and find a list of them online, but these are some of the more common ones, and I'm going to use these as the examples for today. Now, if you actually want to go and calculate a hash, if you have a Linux machine, this is very, very easy. The Linux OS is going to come pre-built with a lot of hashing functions in it. So if you go and you download an image, in this case, I've got this image.png, and you just run MD5 sum. That's the name of the program. And then you specify the file name. You'll be able to get the MD5 sum just like that. So we've got MD5 sum. We also have SHA-1 sum, and we have SHA-256 sum. So very, very simple. It's literally the name of the hash with sum and then the file name. And I believe most Linux operating systems are going to have a lot more different hashing functions pre-built in there. And you can definitely go online and look those up. Not only can you calculate hashes from the command line, but there are plenty of other tools on the internet that will do this for you. So you could go to CyberChef. I think if you just go and type in Google and you type in online MD5 hash, you can find a lot of different services that will verify that will generate these hashes for you. Now, be very, very careful when you're using those online tools because not all of them are reputable. Some will actually download and keep a copy of the files that you want to get a hash on, and you don't know what the heck they're doing with that. It could be something nefarious. So be very careful when you're using those. And some of them can be inaccurate. For whatever reason, they might have a bug. I've seen a lot of online hashing services which will work perfectly fine with text, but when you upload a file, it gets it wrong. So just be mindful of that. Always make sure that you're using reputable sources, reputable tools. Okay, so how do we actually verify the sums ourselves? So we can calculate the sums. How do we verify them? What you can do is a before and after. So what you will want to do is either take the MD5 sum that is listed from the source that you're downloading it from. So maybe you're downloading a file from the internet and it gives you an MD5 sum or another hash. And you just run MD5 sum on your version after you download it, and you just visually inspect, are these the same or not? That's nice, but like no one wants to be verifying individual files one at a time. That's a huge pain. So there's actually a way to do it in bulk. So you can actually take the hashes, save them into a file, and then run the respective hash sum program in Linux with that file, and it will go through and verify and check to see if everything is okay. So in this screenshot I'm showing you right now, I have a file of MD5 sums called integritycheck.log. And when I run my MD5 sum with that integritycheck.log, you can see there's a lot of text. There are like 1,000 different entries. You see the last couple of entries here. Okay, 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 okay. But then at the very bottom it says, warning, one of these did not match. So I was able to verify the integrity of 1,000 different files, and one of them did not match. And I can go back into the history and see which one that is. Now, this is going to be what a lot of different enterprises will be doing rather than doing the individual. Let me just check one file at a time. They'll have one big list of the hashes and they'll verify them all in one shot, and usually in automated fashion. I've seen this used in security where, let's just say you have some folders, some files on your machine that should not be modified. They should remain the same. And what you can do is you can get the file sums of those, the hashes of those files, save them into this integrity log, and then periodically go and run a checker and verify to see if anything has changed. If something has changed, that means that something's wrong. Like, did you inadvertently make a change? Did a hacker come in and plant some malware? This is especially helpful when you're looking at system files. So let's just imagine you're on a Windows computer, you've got like System 32. Those should not just be getting updated willy-nilly. Maybe someone's installing a rootkit in there, if so. And there are the kind of what I would say the low-tech ways of verifying this by using something like a MD5 sum or a SHA-1 sum. But there are also more enterprise-grade tools. I believe like Tripwire was something I've saw years ago, where it will take a snapshot effectively of, it'll do MD5 sums on, or hashes on all of these files in a directory on your computer, and it'll check periodically. And if they don't match anymore, it will give you an alert and say, hey, something's going on. So this becomes very, very helpful. All right, so let's go ahead and try it out ourselves. All right, so I have my virtual machine here. I'm in Cali, and we're going to try a couple things. I have a little bit of notes here on the side, and apologies that my head's going to be in the way of this a little bit. But those bottom notes are primarily for me than they are for you. But we're going to have 3 different tasks we're going to perform. The first thing we're going to do is we're going to create some sample files and calculate their hashes. After we do that, we're going to tamper with one of them and verify that the hash is no longer the same. And then after that, we're going to do what I showed you in that last slide, where we're going to take a large number of different files as well as a log with all those hashes and identify the one that has been tampered with. So I have a quick command here for just generating some random test data. I'm going to use the OpenSSL program, and I hope I still have this installed on my machine. So this OpenSSL command is going to generate 128 random bytes or bits. Let me see. That looks like 128 bytes. And you can see here, this is completely gibberish. Every time I run it, it is giving me a different output. Not very helpful for me to save that on the screen. So what I'm going to do is I'm going to save that to a file. I'm going to call that out1.bin. And then I'm going to do an out2.bin and an out3.bin. So now we have three. We have out1, out2, out3. We have three randomly generated files. And if I try to print them out, actually, let me do a hex dump so it is a little bit easier to see. If I do hex dump out1.bin, and I am only going to look at the first line just so that we can all see that these are indeed unique. Okay, so you can see here we have out1.bin, out2.bin, out3.bin, and these are the values, the beginning of those files, and they're completely different. Like none of these match. So we have three randomly generated files, and I'm going to calculate an MD5 sum on each one of these. So we have out1.bin, out2.bin, and out3.bin. Actually, what I should have been doing is saving this to a log. So I'm just going to call this hashes.log. So out1.bin, 2.bin, and out3.bin. Perfect. So if I look at my hashes.log, you can see here are my three randomly generated files with their three corresponding hashes, and they're all very different. Now, what I'm going to do is I am going to overwrite one of them. So if I go back to my OpenSSL command, and I'm going to overwrite out2.bin with a new set of random characters. And if I do that and I run my MD5 sum on out2.bin, you can see it no longer matches. Right? These are completely different. So we know it's been tampered with. But if I go back and I run MD5 sum on out1.bin, that's still the same. If I run it on out3.bin, that is also the same. Those were not touched. Those are exactly the same. And let me show you how even making a tiny, tiny change in one of these files is going to be giving me a very, very different hash. So I'm just going to go to the end of this file, and I'm going to add a 0 to the end of the file. So it's basically the same. There's just a 0 at the end. And if I run MD5 sum again on 1.bin, it doesn't match anymore, right? It's completely different. I'm going to try and remove that 0. And hopefully, yeah, I think because I opened it up in a text editor in Vim rather than a proper hexadecimal editor, I permanently messed up this file now. But let's show you actually how to verify all of these in bulk using our hashes.log. So we're going to run MD5 sum -c, and we're going to pass in this hashes.log. And when I run this, you can see here, 1 failed, 2 failed, and 3 is okay. And we've got 2 checksums that did not match. So that's pretty neat. And if I want to go and say, all right, actually I did intend to make a permanent change to out1.bin, what I can do is just calculate the MD5 sum of out1.bin again. And I'll just go copy that, go to my hashes.log, and I'm just going to update. I'm just going to update the record that I have in here. And say, okay, that's fine. This is the new hash for out1.bin. And now if I run the bulk check again, out1.bin is passing again. Now, keep in mind what I said at the beginning. MD5 sum is technically a broken hash. It's not super secure. So I would recommend, if you're trying to do this for real, using a different hashing algorithm like SHA-256, which is a lot more secure. But MD5 sum is still super common. And it's one of the fastest hashing functions that you'll see that's in common use today. And for the purposes of this demonstration, it works just fine. So let's go and complete our final task, which is identifying from a large set of files which one is invalid, or has been tampered with. So I'm going to delete my hashes.log. I'm going to delete my out1.bin, my out2.bin, and my out3.bin. So those are all deleted now. And so I have my integrity check.log. And you can see here, there are all of there's 1,000 records in here. So we definitely don't want to verify these by hand. Let's do this in bulk. MD5 sum, integrity check.log. And I can see one did not match. Now I could scroll all the way up in here. I'm not going to do that. I'm going to run grep. And I'm going to look for failed. And I can see here, this is the one that failed. Now, one thing to keep in mind is that when you are creating this log when you're creating this file that is storing the hashes to do the verification, the file name / the path to that file is included in the verification log itself. So you can see here that when I run the MD5 sum with the -c option with this integrity check.log, it is going to go into this samples folder and then look at 0.bin. So if I don't have all of these files in the samples folder, it won't run. It won't work. It'll fail. So just keep that in mind. But I hope you all found that helpful. There are a lot of different things that you can do with hashing. I would highly recommend that you just try this out yourself. Go and just create some random data and see what happens when you make some modifications, and maybe even go and create some integrity logs of like a downloads folder or something else that you have on your computer, and just see if you detect any changes when they happen. But other than that, best of luck with the rest of your learning. All right, so I've finished the demo. I'm going to go to all the questions that I see in chat. If you've got other questions right now, please ask them in the chat, and I'll see what I can do here. Thomas is asking, can you use this for code integrity? Yes, you can. So the data that gets put into the hashing function, it can be any data, any type of data whatsoever. So that could be a binary file, it can be plain text, it can be code, it can be anything. You can do that to verify code integrity as well. And in fact, very common code management systems like Git will use hashing to verify when things have been changed, not necessarily from like a security perspective, but just from a management perspective. If Git is going to be keeping snapshots of all the changes you make over time, they don't want to create snapshots of things that haven't changed. It's just duplicate storage, and it's not a good use of space. So yes, you can do it with code as well. Adrian is asking, why would the hash be different on the same file with different hash software apps? The reason why they would be different is because one of those apps is incorrect. So hashing functions will the ones that are commonly in use, they're going to be public and accessible online with the specification for how the hashing function is supposed to work. If you have an app that is giving you the incorrect hash, it means that the app is coded incorrectly and is making a mistake. It's not following the specification properly. Lisa is asking, to analyze, would you have to either create the original hash or have two log files to compare? Yes. So you either need to create your own hash in like a before and after. So when you know that the file is currently valid, you take a hash, and then the next time you need to check, you take the hash again and you see if those two hashes are different. That's if you are maintaining access to that file yourself. Now, if you're getting the file from someone else, they can give you the hash and you download the file, and then you can run the hash again on the version that you have and just verify that your hash matches their hash. So you will either need to create the original hash or like have the two different hashes to compare. All right. Marion John is asking, does antivirus software work on this principle? So it used to be the case that like the original antivirus worked on this principle where they would say, oh, this is a virus. Let's get a checksum on, we'll get a file hash on that virus. And then we'll have a giant list of all the hashes of all the viruses that we know of. And then we'll just scan your computer to see if you match any of those. The reason why that's a terrible idea is because, as I showed you in the demo, if you just make a single character change, you get a completely different hash. And so if you're making a virus, just make different versions of the virus that have like an extra space at the end. Like just make some very small tweaks and now you can bypass the antivirus. So then antivirus has evolved so that they no longer just, instead of doing hashes on the entire file, they'll look for specific signatures. So they'll look for specific sequences of characters or binary data within a file, and then it'll determine, oh, if I see the sequence within the file, that means it's a virus. Now they're even more sophisticated. You've got antivirus, which is going in and checking for the behavior and actually looking at what the programs are doing and seeing what they modify and identifying if they're modifying things that they shouldn't be modifying. And those are more like heuristic and behavior-based antiviruses. That's more of the norm today. So that's a great question, because yes, the original antiviruses, they've relied entirely on hashing, but the modern day ones today, they are a lot more sophisticated and they don't really utilize hashing to that extent. I'm sure they use some level of hashing, but not the very simple, hey, let me get a list of all the virus hashes and check to see if you have any files that match one of those. And then a question on why do we encounter a problem when we opened the file in Vim and edited it. So I'm fairly certain the reason why there was a problem is because I opened up a binary file and I was in text editing mode. And so something went wonky there. And so when I saved it, it probably made a change that I wasn't expecting it to, because I was in text editing mode. All right. Well, that looks like all of the questions on my end. Thanks everyone for showing up to our live show. I hope you found that to be educational and you've learned something new. And best of luck with all of your learning. Take care.